let's go to the first one. You are required to determine the refractive index of material of glass prism using a laboratory spectrometer. A. Draw the path of monochromatic ray incident on surface AC undergoing minimum deviation through the prism shown in figure 1. Right. Also mark the angle of incidence I and the angle of refraction R at the surface AC. Right. Listen, now if that says minimum deviation, right? We know at minimum deviation, our ray diagram is symmetric. Our ray diagram should be symmetric across the prism angle, right? Should be symmetric across the prism angle, right? Then that is very important when you draw the diagram. Otherwise, if that diagram is asymmetric, no marks will be given, right? It should be a symmetric one. When there is symmetric, always the refracted ray becomes parallel to bottom, BC. Always refracted ray becomes parallel to bottom, right? Second, right, right. See, let me use the ruler. Say this one is the incident ray. Say this one is the incident ray, right? And here this one is the refracted ray. Neglect the unwanted parts, right? Now it's correct. And say this is the emergent ray, right? Right now, fine now. Then have to draw the normals. Then here we have one normal, and here we have another normal for this surface, right? Then angle of incidence is here, right? Have to put these arrows also. Putting arrows is a must, right? Putting arrows is a must, right? And angle of refraction is here, or angle of refraction. Then angle of deviation is the angle between the original direction of light ray, this one, and the final direction of light ray, this one. Angle of deviation is here, right? So this is how it should be, right? Next, mark the angle of minimum deviation D. I marked it already. Mark the angle of minimum deviation D of the ray in the above figure 1. Write down an expression for the refractive index N of material of prism in terms of angle of prism A and D. Right, that's a proved equation. Right? We know N equals, right? It's a proved equation. No? That's a proved equation. N equals, we know, sine A plus D over 2 over sine A over 2. That's a proved equation, right? Next one. Give the experimental steps needed for adjusting the telescope of spectrometer, right? So when we adjust the telescope, there are steps, there are sequence in those steps, right? First thing is, in telescope, we know it consists of eyepiece and objective piece. First of all, we have to adjust the eyepiece, right? To adjust eyepiece, what we do is, right, first listen, to adjust eyepiece, what we do is, have to adjust the eyepiece until a clear sharp image or a clear symmetric image of crosswires are seen, right? Then once the eyepiece is adjusted, then telescope should be rotated and focused to a distant linear object, and the image of a clear symmetric image of that distant linear object can be a tree or can be a pole, a column, something like that. Distant linear object and a clear symmetric image should be taken to the crosswires again. Then from the first step, eyepiece will be adjusted. From the second step, objective piece is adjusted. When both are adjusted only, right, telescope will be adjusted. Okay, right this way. First one, adjust the eyepiece. Adjust the eyepiece. adjust the eyepiece until a clear symmetric image of crosswires is seen, right? That is the adjustment of eyepiece, and then the adjustment of objective piece. For that, we have to focus it to a distant object, right? Then focus telescope to a distant object, distant linear object, to a distant linear object, and adjust objective piece. Right? No need to adjust the eyepiece again because that is already adjusted from the first step. Right? Now second one, focus telescope to a distant linear object and adjust objective piece until a clear symmetric image of object is seen on crosswires. Right? These two are the two complete answers. Right? The given space is enough. Right? Now when I write here on the screen, this is not my usual handwriting. I mean the size. This is not my usual size of handwriting. Right? I'm writing a little bit larger to you to see properly. Otherwise, the given space is enough. You have to manage the space to write this thing within 3 lines. Right? Next, a student argues that a beam of light from a bright filament bulb can be used for the leveling prism table. Do you agree? Beam of light from a filament bulb. Yes, possible. What's the reason? When we level the prism table, right, what we use is the reflection of light. No? To level the prism table, we use the reflection of light, not the refraction. That's the reflection. Since there is reflection, right? Whether we use a monochromatic light or white light or any other bulb, doesn't matter. That's a reflection always. Doesn't matter. Right? Then the question is, do you agree? Yes, we agree. Give the reason. Reason is to level the prism table, right? We use the reflection of light, right? Then no issue. Give the reason. Reflection of light is used. Reflection of light. Reflection of light is used to level the prism table. Right? Now, if it was a case regarding refraction, then it matters because due to refraction, color dispersion occurs, no? Right? Because white light can use if the color disperses. But here, since there is a reflection, no worries, totally fine. Right? After adjusting all the parts of the spectrometer, how do you experimentally obtain the minimum deviation position for the monochromatic ray of light? Right? Monochromatic ray of light. Okay. Monochromatic ray of light. Right? For that, it should be monochromatic because for minimum deviation, we use refraction. Refraction white light use that's a refraction. That's the thing. Right? Then how to mention these steps in the correct sequence. These steps should be mentioned in the correct sequence. Right? Right this way. Usually we use a sodium lamp. Right? Usually we use a sodium lamp in the lab. That is called the sodium lamp. In the experiment also, when we do the discussion, practical seminar, also I told you that is called a sodium lamp. Right? That is called a sodium lamp. Then since that word is given in the guide always, you have to use that word sodium lamp. Right? Then how to say that use or keep a sodium lamp in front of keep a sodium lamp keep a sodium lamp keep a sodium lamp in front of objective piece of telescope or in front of objective piece, right? Objective piece. And when keeping the prism, there are things to be followed. Now, no need to mention everything here, right? Then when we keep the prism, we know something additional, but this is a background related, right? When you keep the prism, one vertex of the prism should be at the center of the prism table, and one side of the prism should be perpendicular to a line connects two pins on the prism table. PQR pins, right? Over there, the end, right? Then next one, keep the prism on prism table properly. Properly means that should be how I explain, right? Properly. And we are going to get the small angles, no, right? We are going to get the small angles, right? After keeping this, have to rotate it to a small angle, right? Have to rotate it to a small angle of incidence, right? Keep the prism on prism table properly, and rotate, adjust or rotate, adjust scale and adjust the table to get a small angle of incidence, a small angle of incidence, right? Now, here comes the most important thing, right? Here comes the most important thing. Now, we have to rotate the prism table, right? We have to rotate the prism table by looking at by looking through the opposite side of the prism, right? I have to rotate the prism table by looking through the opposite side of the prism, and we will see one position, right? We will see one position, right? At that point, the image returns, right? It moves in a particular direction and it turns to the opposite direction, right? That turning point is called the minimum deviation, right? That turning point is called the minimum deviation, right? So turning image is a keyword. Turning image is a keyword. Or switching the direction is a keyword, right? Switching direction, turning, returning, likewise, that is a keyword. That's a keyword. Next one, rotate prism table. Rotate prism table by observing image through opposite surface, right? Surface, and get the reading when the direction of when the moving direction of image of slit, right? What we see is the image of slit, image of slit. Reading when the moving direction of image of slit is switched, right? That's a complete answer. This idea must be there. This idea must be there. This idea must be there, right? G. When the telescope is fixed to a minimum deviation position, the circular scale and the vernier scale positions are shown in the figure 2. What is the reading of the position? Right, what is the reading of the position? Then before vernier 0, see, now we know main scale of spectrometer is in 0.5 degrees, right? Main scale of spectrometer is in 0.5 degrees, right? Main scale. And vernier scale is in minutes. Vernier scale is in minutes. Right? Then 140, 141, 42, 43, 44 completed. 144 completed. Right, so we know final reading is the reading of main scale plus reading of vernier scale. The reading of main scale is 144. That is in degrees. 144. Right. Then find the coincided point. Coincided point is here, this one. Right. 15. Then 15 minutes from the vernier scale. That is directly 15 minutes. 144, 15 minutes. Right. Next. After removing the prism from the prism table, the direct reading of the telescope is measured as 104.55 direct reading. Right. So what is done here is this. No, quickly. Now, if this is the prism, right, one reading is taken at the minimum deviation here, say R1, and then the other reading is taken after removing the prism here. Then difference between these two measures the angle. Difference between these two measures the angle, right? Angle of deviation. That's the angle of deviation. Then just the difference between these two is the minimum deviation. That's it. Try right, see. Then that's why direct reading is given. Direct reading is 140, 104, 55. Find the value of D. The 360 mark of the circular scale has not crossed when taking measurements. What's the importance about that? If the 360 mark is crossed, when we take the readings, you have to take reading as 360 minus difference. Right, now, if that is not crossed, which means both readings are at the same side, get the subtraction. Then D equals, right, from 144, 15, subtract 104, 55, right? Just a simplification, right? 15, 55 again, you have to take 60 from degrees, then 75 minus 55, it becomes 20, then 143 and 104 means 39, 20, right? 39, 20. I, if the prism angle is 60, calculate the refractive index N of material of prism. Use the natural sine table for your calculation, right? Then have to find some sine value also, right? Then apply now equation. We wrote the equation initially first, right? N equals, right? No need to write again when you are doing the step here. This is for your reference. Sine A plus D over 2 over sine A over 2. Applying the equation. Sine, then A is 60 plus D. D was 39, 20 over 2 over sine A over 2, 60 over 2, right? 60 plus 39 is 99, 20, no? 99, 20, then divided by 2, 49, 49, 40, right? 49, 40. Sine 49, 40 over sine 30. Right? Sine 30, we know, then have to find sine 49, 40. Have to find sine 49, 40, right? Let me share the value. Sine 49, 40. You can check from the sine table, right? You can check it from the sine table. It's coming as 0.7622. You also can check with the sine table and see 0.7622. Right, this is half, no? Then that times 2. Right, it is 1.52. It is 1.52. Final answer 1.52. Final answer 1.52. Right, you also can check with the table, check with the sine table, right? Right. So we have come to the end of the first question. Right? Ask if anything before moving on to the second.